Сегодня у нас второй день, и он посвящен вопросам электроэнергетики, хищные птицы и электроэнергетическая инфраструктура. И первая половина данной сессии будет посвящена линиям электропередач и проблемам, связанным с этим. Для первого доклада приглашается господин Азаф Мэйроуз.
Okay, good morning, everybody. So today I'm going to talk about how we prioritize the insulation of electricity pylons by a GIS model. And it's work being done under the framework of the Spreading Wings project, which is an initiative by the Israeli Electrical Company together with the Israeli Nature and Parks Authority and the Society for the Protection of Nature. Yeah, should I wait for more people? Yeah.
Уважаемые участники конференции, давайте мы проявим уважение коллегам и организованно будем участвовать, слушать, вовлекаться в тему. Тема очень важная, одна из самых интересных. Спасибо.
Yeah, thank you. So around 2018, we came to understand that electrocution is literally killing our Bonelli's eagles. You see more than 70% of all the known mortality cases were electrocution. We performed a viability analysis and we saw that without taking care of this problem, we will definitely lose our population. So the model aims were to facilitate Bonelli's eagle population recovery and to direct the mitigation efforts towards the most dangerous power poles, since we cannot correct the entire network. It's a very expensive and slow process. To quantify the number of pylons that need to be retrofitted in order to reduce electrocution risk by at least 80%. And mostly important, to promote a proactive approach to electrocution mitigation rather than the reactive approach that has led mitigation efforts until that time. Means we were used to insulate only the pylons that were found deadly or killing eagles. So we wanted to change that and start mitigate proactively. So the model focuses on juvenile Bonelli's eagles in their dispersal areas, which are very different from the breeding territories. And we also map the dangerous pylons in the breeding territories by a different process, which I wouldn't describe right here. We don't have enough time for this. Anyhow, our challenge was that the GIS layers of the electricity grid or the structural elements of the pylons themselves were not available for us as a matter of confidentiality. But we did manage to receive a layer of pylon density, given as the number of pylons in a 500 meters radius of each pixel. Each pixel is of 100 meters, and we got a layer of the density, and we could use it. Because of this reason, we decided to use a maximum entropy modeling, a maxent model, which is a very commonly used in ecological studies as a species distribution model. But here we modeled the potential risk, as I will show you in a minute. So we ran the model in 3 stages. In stage 1, we predicted the immature eagle distribution across the country. And we later on used this layer as an explanatory variable in the 2 other stages. Okay, so in the first stage, we are just predicting the eagle distribution. Our presence observations were telemetry records, and we used the 10 explanatory variables as topography, climate, and so forth. In stage 2, we took the same 10 variables plus the predicted distribution that was made in stage 1. And here the present observations were documented Bonelli's electrocution events. Okay, so the species in stage 2 that we want to model is electrocuted eagle. Okay, it's the same as in stage 3, but the difference between the two stages is the addition of the layer of density of existing power lines, existing power pylons. Okay. So this is the present data that we used. This is the telemetry data of about 30 individuals. Some of them were tagged in the wild by Walter, and some of them were released from the captive breeding. And about 40 electrocution records. Each red dot here is one electrocution event, and you can see that they are spread, especially along the Jordan Valley, or the Judea Plateau here, or the northern valleys, which are the dispersal areas of the eagles in Israel. So this is the list of the explanatory variables, and I wouldn't go into details here, but this is the first stage, this is the second stage, adding the product of the first stage of the model, the Bonelli's dispersal distribution, and in the third stage, we also added the number of pylon density. So these are the results. Okay, this is the eagle distribution prediction. Okay, the outcome of stage 1. This is the outcome of stage 2, and this is the outcome of the third stage. Let's go over them quickly. So each pixel here stands for the probability of eagle presence. Okay, so it got a value of between 0 to 1. It's a probability value. And this map was used as a predictor variable in the second and third stages. Okay, this is the second stage, and you see that the riskiest, the most risk areas, the ones in dark red here, are within the higher probability dispersal areas that we saw in the previous stage. But within these areas, it has highlighted all water bodies and their surroundings, like fish ponds, artificial reservoir, etc. I will show you in a bit. So this map can be used for the correct planning of new infrastructures because it has nothing to do with the existing power line, okay? Whereas this map, the third stage, we enter the information regarding the existing power lines, so it can be used to correct the existing network. And you see it's even more specific. So these are the relative weights of each of the explanatory variables. It has a value, which means the contribution of each variable to the model. And I wouldn't go through all the numbers, of course, but you can see very clearly the most important one. Like distance from water reservoirs was not an important variable in the first stage, like to describe the general distribution of the eagle, but it was found to be very dominant when we entered the world of risk, when we modeled the risk for the eagles. So there is something here we understood around water reservoirs that makes their environment specifically risky for the eagles. And we can also see it here in this graph that shows the number of electrocution events in relation to distance from reservoir, okay? So we see like more than 60% of the actual electrocution events occurred on the bank of the reservoir, like 200 meters from the reservoir. And we can also get the impression here on the map, which every red dot here is electrocution event, and these are water reservoirs, and you can see how they are all happening really close to these water bodies. So I understood that these water reservoirs are actually acting as an ecological trap, because they are hotspots for birds and biodiversity in general. And they host plenty of waterfowl that are taken as prey by the eagles. But in order to hunt near the reservoir, the eagles are typically looking for high perching point. But unfortunately, the only perches that are available for them in the vicinity of the reservoir are the power lines that are leading the power to the reservoir's control and pumping facilities, after all the trees were removed when the reservoir were initially constructed. So the combination of these circumstances has apparently created a detrimental ecological trap. And you can see one example here. This is a pylon that happened to kill 2 Bonelli's eagles, one after the other, and it is overlooking 2 of these reservoirs, and you actually can get the impression of why the eagle is tending to stand there. So after building the model, we saw that about 80% of the electrocution events are falling within the 2 highest risk levels, which together represent about less than 4% of the entire network. While we were working on the model, 9 more Bonelli's eagles got electrocuted, and 8 of them occurred on pylons in the highest risk area. So we got the approval that the model is actually working, unfortunately. Here I'm not going to get into the details, but we wanted to see if we are correcting the network according to the model, how it would impact other species of birds of prey and birds in general. And we see that it potentially has also a very good impact on the imperial eagles that are overwintering in Israel, ospreys, white-tailed eagles, especially black stork, which is wintering in good numbers. So to conclude, the Bonelli's eagle is a critically endangered species in Israel, with electrocution posing a serious threat to the mere existence of its tiny population. In order for the population to stay viable, to become viable, we have to retrofit most of the dangerous pylons, both in the breeding territories and in the dispersal areas. The model that I presented here yielded actually 2 risk maps. The first map covers a larger area that currently doesn't have to have any electricity networks. So we are using this map for supporting the planning of new power lines. But the second map is now being used to guide the modification of the existing network, since it has the layer of pylon density, as I showed you. As we saw, the environmental feature with the highest correlation to the electrocution risk is the distance to artificial water reservoirs, which are actually turning to be a detrimental ecological trap. And the strong attractiveness of these reservoirs for the eagles may explain the high level of sensitivity presented by the model, where only about 4% of the entire network is expected to achieve about 80% reduction in eagle electrocution. And this is very exceptional. Usually we're in regular models, we are speaking about 20 to 80, so 20% correction to get the same amount of reduction. So this is very sensitive and selective. So the number of high-risk pylons in the dispersal areas is estimated at 5,000 pylons that needs to be corrected in these areas. And these are also the breeding territories where about 1,000 more pylons are nominated for correction. So in total, we need to correct about 6,000 pylons. And we are treating this model as a master plan for mitigation because it didn't have any information about the technical structure of the pylons, which is also very important. But this master plan was very efficient for us to understand the extent of urgent insulation needs, to prioritize the areas for retrofitting, and to estimate the budget and mobilize proactive mitigation process, which we indeed managed to do. And we are in the middle of this process. In the last 2 years, we mitigated about 2,000 pylons. This is here in gray in the back. You see the number of electrocutions here. In red, these are tagged individuals that got electrocuted, and in green, these are non-tagged. And most importantly is the yellow line here, which is the ratio between electrocuted eagles per tagged individuals. And we see that there is kind of reduction in the number, although it is too early to say that, and we're even not gone with the 2023. We're still having some very risky months ahead of us. So as we Jewish say, we say knock on wood, and we are really praying that this trend will continue on and follow in the next years. And I'm hoping to be here again in a few years and be able to report that we are indeed succeeding, and the number is going down and down. Yeah, thank you very much.
Спасибо большое, Асаф. Вот вопросы. Давайте вот 2 вопроса сейчас зададим. В принципе, у нас будет еще время пообщаться в перерывах.
Did you estimate the performance of your model?
Yes, as I didn't told it, but we built it with 80% of the observations, and we used 20% for the approval of it. But unfortunately, we are testing it all the time because we have many electrocution events. And as I said, during the time that we built the project, we had 9 events. 8 of them fell within the highest category. So apparently it is working. And since then, we had 10 more events or so.
What value of area under the curve?
Excuse me?
The main feature for estimating of the model performance is the area under the curve,
yes.
rock operation, receive operation curve. What values of?
Yeah, we received higher value, like about 0.9 or something, depends on the stage. I don't remember the numbers exactly. We are working on the paper. I mean, it should be published soon. We get all the numbers there. I didn't want to get into such details here. Yeah, we can talk later on.
I just want to add that in addition to protecting the power lines, we added purchase, which is also a good solution, just to add other purchase that are higher than the power lines, and then you lower the risk.